Okay, so today we're going to be working out of section 3.1, and our goal here is to be able to graph what are called linear systems of equations, meaning we have multiple linear equations, and we want to know what the solution is, or another way to put it would be where do they cross. And I'm going to show you how to do it by hand, but I'm also going to show you three different graphing utilities that you have access to in one way, shape, or form. And so what we're going to do is we're going to start with number 6 from 3.1, and we're just trying to find the solution for these two lines. And so the first thing I need is I want these in y equals format. And so what I'm going to do is I'm going to subtract an x here from both sides, and then I'm going to end up dividing by 2. So I'll get y equals negative x plus 2, and that's right, it's 2y, and then I'll divide everything by 2. So what I'm going to end up with is y equals, this is a coefficient of 1, so I'm going to call that negative 1/2 x, so that I can see the slope clearly, plus 1, because 2 over 2 is 1. All right, so what I'm going to do now is I'm actually going to erase this. If you need to go back or pause it, you certainly can, but I'm going to erase that, and I'm going to push all this stuff back up here. This is my equation, my first equation. Let's look at working the second equation down. First thing I want to do is I actually want to move the 4y. It's negative. It'll be easier if it's positive. I'll still have to do an extra step this way, but I can also subtract 14 at the same time to save myself a step. So x minus 14 is equal to 4y. And so now I need to divide everything by 4. So that y equals, this is a 1x over 4, so 1/4 x minus, and 14 over 4, they're both divisible by 2, so I'll say 7 over 2, or 3.5 if you want to go that far. So what I'm going to do is, again, I'll come in, I'm going to erase this mess that I've made. You guys wouldn't erase it, but I just want to be able to work cleanly here, so you might do the work somewhere separate. The graph is not your answer, and I want you to understand that today. Your graph is actually the point where they intersect. So if you don't graph these because you're using some sort of a graphing utility, that's totally acceptable. But this graph is for those of you who want to try and attempt it by hand because you don't have access to one and don't want to wait till Monday. So this first graph, it has a y-intercept at 1, and it has a slope of negative 1/2. So down 1 over 2, down 1 over 2. So I'm going to get a line. I'm going to connect a line through all these points. All right, very good. Right through there, and I'll even extend it on down here. Now I have a special advantage. See, I've got a grid that's all squared up, and I also have a line that's going to be perfectly straight, so it's going to be easier to work with. Over here, I have this b value of negative 3.5. So if you go down 1, 2, 3.5, I'm about right there. And then I'm supposed to go up 1, which will put me here, and over 1, 2, 3, 4. Okay, it's right about there. And then I'm supposed to go up 1 again, and over 1, 2, 3, 4, and put a dot there. Now, I'm hoping that with all these tools that I have access to, that I can be pretty accurate with where the intersection is. It's not perfect, but it looks like it's probably right around 6, negative 2. So I'm going to go ahead and say that my point is at 6, negative 2. Hopefully that's the answer. The way we're going to check the first one is using just a standard graphing calculator. And so if you have access to a graphing calculator, this should make sense as we go through this. First thing I'm going to do when I turn my calculator on is hit the y equals key right here. That'll lead me to this page and clear out anything that's there. And I'm going to start by typing in the first equation. Now I still have to have it in this y equals mx plus b, or y equals format for me to use a calculator. So the algebra is still useful. But I'll take negative 1 divided by 2, x is right there, plus 1. And I go to the second equation. I type 1 divided by 4x minus 7 divided by 2. And I'm going to go ahead and graph. And there's that intersection that we're looking at. It looks pretty much the same. So hopefully I did this correctly. Let's second. You hit the trace button. The second option of trace is calculate. And then the fifth option down is to find the intersection. It's going to ask me a series of questions which are really probably kind of dumb for what we're doing. So I'm just going to hit yes 3 times, so enter 3 times. And it comes up with 6, -2. And I found my intersection. So whether I use a graphing calculator or I use by hand method, it is possible, but it's going to be difficult if you're not using graphing paper. So we move to number 20. And again, we need to make sure that we have a y equals format. If I look at the first equation, I have that. So I'll go ahead and graph it now. Starting at -1, going up 2 over 1, up 2 over 1, and I can put the curve or the line right through those points. And even extend it down that way. Okay, so I've got my first curve drawn. Now I switch to my second curve. It's not in the right format, so I'm going to add 6x. I'll get 3y equals 6x minus 3, divide by 3. I get y equals 2x minus 1, which, if you notice, is exactly the same as the original. So when I see this exact duplication, algebraically, I already know that this has infinitely many solutions. And so that is the answer. Every point is part of the answer, and that's way too many for me to count. So we'll say that there are infinitely many solutions. But let me show you how I would draw this on graphing calculator. Situation like this. If you actually go to Moodle, and you go into Moodle, you can find this free graphing utility. If you go through the process of downloading it, you end up with a program that looks like this. And so we're actually going to graph this on here. And so, where did it go? Right there. So what I'm going to do is I'm going to type in, I'm going to pick this piece right here. Click on it. I'm going to type in the equation, which is 2x minus 1. Okay. I say OK. And it produces the graph that I'm looking at. Now let's say that I wanted to graph the other one, but I hadn't done the divided by 3 completely. So I'm going to come over here. Let's say that I had y equals 6x minus 3 all over 3. See, now I can't tell that they look identical. It's solved for y, but it's not simplified completely. So let's see how it would look if I typed that in. Again, I pick a function. I would need parentheses around the numerator to keep the calculator from misunderstanding. So parentheses, 6x minus 3. I'm going to close the parentheses, and then I'm going to divide by 3. Okay, but I'm going to change the color here because I don't want to misunderstand. I'm going to do it in dots just so that I can see the difference between the two of them. And I'm going to click OK. Now you can see that they're right on top of each other because if I get rid of one of them, it becomes clearer. I can remove one by checking and unchecking. So we can see that they are literally right on top of each other. And if you notice down in the corner right here, that when I move my mouse around, it tells me the x and y coordinates for where the mouse is. And so if I did see an intersection, like let's add one of these guys in. No, not that one. Let's add this guy in. I could find the intersection by putting the mouse as closely as I can to that. Now this is not a real problem from your homework, but that's how we would find it, by looking down in the bottom right corner. But that's how we can use this graphing utility, which is actually pretty slick. There is one other way, and we'll look at that here next. We have this last quick set, number 28, and we want to solve it for y again. So I'm going to add y to both sides to make it positive. That gives me 5 halves x equals y minus 4. So I'll add 4 and get y equals 5 halves x plus 4. Okay, some simple algebra. I know I may be going a little fast. Slow it down. Hit pause whenever you need to. That's fine with me. I've got that equation, and I can go in and graph it. Oops. Add 4, and then a slope of up 5 and over 2. That's pretty steep, but we'll get it in there. Okay, so there's that line. And then I need to work on this line over here as well. And so, oops. So what I'm going to do is I'll add 2i. And then subtract 1/4. So 5x minus 1/4 equals 2y. And this is a mess, so I'm just going to divide everything by 2. And this may seem a little bit rough, but it's all there. So y equals, parentheses, 5x minus 1/4, all divided by 2. I can simplify this, and we'll talk about that simplification process later on in the semester. But for now, we're just going to take it and throw it into a calculator anyway. It just makes the way we type it in, we have to be a little more careful. Could I do this by hand? Yeah. What I'd have to do, though, is to rewrite this as 5 over 2 x minus, what's half of a 4th? Well, that's an 1/8. This becomes difficult to work with. I mean, I'm sitting down here finding my x-intercept, my y-intercept right there, negative 1/8. This is a mess. How I'm ever going to really figure out where the solution is, that's going to be tough. Those of you who know something about slopes, though, might already know the answer to what this problem is going to tell us. Let's take our last option of how we can do this with the graphing utility. This is sort of for people who have the internet but nothing else, and don't really want to download something to their computer. If you go to wolframalpha.com, you can see that right here or there. What I'm going to do is I'm going to type in the equations that we had, and I'm going to have them graph it. So I start with y equals, and it's going to come up with suggestions. I don't want any of those. Equals 5 divided by 2. I need to be careful to make sure I'm doing this correctly. So 5 divided by 2 times x, and it was plus 4. Plus 4. Is that correct? Let's check that real quick. Yep, plus 4. And then, comma, for the second equation, y equals, now I'm going to write the unsimplified version. So, parentheses, it was 5x minus 1 divided by 4, okay, close parentheses, divided by 2, okay? So let's go ahead and we're just going to hit enter, and we're going to see what the computer comes up with for us. Okay, so it's trying to recognize the inputs, and look, I have my 2 lines, and it tells me which one is which based on the equation, and it even simplified it for me. Down here, you'll notice that there are alternate forms, okay? And so we're starting to look for an input, or a solution. If you notice, it doesn't tell me that there's a solution. And if you also look at the lines, it looks like they're parallel. Well, parallel lines will never cross. And so this is going to be no solution for our answer. So right here, I can just come in and put no solution and be good there. If I go back to the Wolfram Alpha, though, I just want to show you what happens if I change the slope. So I delete that, or let's say I make it a negative 5/2. Now when I hit enter, this is a different type of problem. I just want to show you the different options, though. Here, it did produce the graph again. It gave me some different results, but it also gave me the solution. Now, your solutions will be whole numbers today, but if you're at home and you don't have a calculator to graph these things, Wolfram Alpha will help you find the solution to a system of equations, okay? So that is there as an access. Good luck, and we'll see you in class.